All right, guys, welcome to the third part of Unit 5. We have another one to go after this, but it's only half of that section. So we only have labs up to this. So Chapter 12, Mobile Device Forensics and the Internet of Anything. Sounds like fun. Let's go. So here are the objectives. Explain the base concepts of mobile device forensics. Describe procedures requiring data from mobile devices. Summarize the challenges of forensic acquisition of data stored on Internet of Anything devices. It should be IoT Internet of Devices, or yeah, IoT. On devices, anything. It's a little weird. So, people store a wealth of information on cell phones. People don't think about securing their phones. Items stored on cell phones: incoming, outgoing, and missed calls, multimedia services, text messages, short message service, SMS messages, email accounts, instant messaging logs, instant messaging itself, web pages, pictures, video, and music files. Let's face it, this, as replaced with the iPod, was 20 years ago. It's even partially replaced a little laptop, if you think about it. You can do a lot from your phone that you couldn't do in the past. Like 10 years, phones have evolved so much; they've eliminated so many things. So now it's stuff having four things to do: one, record, take pictures, cameras, for example. Um, what else can I think of? Walkmans, MP3 players, those kind of things. Even Game Boys, air quotes. It all became mobile. Sorry, my wife. Mobile devices like your phone. All one item does it all now, right? Items stored in cell phones: continued calendars and address books, social media account information, GPS data, that's a big one, voice recordings and voicemail, bank account logins, access to your home, yeah, if it's hooked up to your Nest at home or whatever you use. I don't personally have anything. My house is not a smart house, so I'm keeping it that way. A search warrant is needed to examine mobile devices because they can contain so much information. Investigating cell phones and mobile devices is a challenging task in digital forensics. No single standard exists for how and where phones store messages, so it's kind of all over the place. It's like the Wild West. New phones come out about every 6 months, and they are rarely compatible with previous models. Looking at you, Apple. Mobile phone technology has advanced rapidly. By the end of 2008, mobile phones have gone through 3 generations: analog, digital personal communication services (PCS), third generation 3G wireless, fourth generation 4G wireless was introduced in 2009. Give me a second, guys. Fourth generation through 2000, and that was over 10 years ago now. Several digital networks are used in the mobile phone industry. 5G is 5G LTE, long-term evolution, expected to be filed in 2020. Yeah, that's already been finalized. But even 5G is going to be supplanted by 5G plus. Then it'll be 6G, then so on and so forth. So I remember when 5G came out, the speed difference was night and day between that and 4G. Believe it or not, that's like going from the old 56K style internet to a broadband connection back in the day. It's like night and day. It's like from going from a drip to putting the faucet full blast. Most code division multiple access devices, CDMA networks, conform to IS-95. These systems are referred to as CDMA1. When they went to 3G services, it became CDMA 2000. Global System for Mobile Communications, GSM, uses time division multiple access, CDMA technique. Multiple phones take turns sharing a channel. The 3G standard was developed by the International Telecoms Union, ITU, under the United Nations. It is compatible with CDMA, GSM, and TDMA. The enhanced data GSM environment, EDGE, standard was developed for 3G. Man, I remember when that EDGE came out. 3G EDGE network. 4G networks can use the following technologies: orthogonal frequency division multiplexing. God, that is a big mouthful of stuff. Multiple mobile Wi-Fi, WiMAX, ultra mobile broadband, multiple input, multiple output, MIMO, long-term evolution, LTE. Main components used for communication: base transfer section, base station control, mobile switching center, MSC. Mobile devices can range from simple phones to smartphones, tablets, and smartwatches. Hardware components: microprocessor, ROM, RAM, a digital signal processor, a radio module, a microphone, and a speaker. Hardware interface is an LED screen. Most basic phones have a proprietary OS. Although smartphones use the same OS as a PC, the Windows phone didn't do so hot, so that got eliminated, kind of like the Amazon phone, the Fire phone. Same thing, didn't last beyond generation or two. Phones store system data and electronically readable program read-only memory, EEPROM. That's a lot to say. I need to look more into EEPROM myself, to be honest with you. So let me write that down. Chapter 12. Slide and have my stuff today. Sorry, guys. I'm recording all this on the weekend. Just I have a busy week coming up. So, anywho, enable service providers to reprogram phones without having to physically access memory chips. That explains how they can activate it from so far away. OS is stored in ROM, non-volatile memory, available even if the phone loses power. Oh. Oh, excuse me. This is only 38 slides, guys, so this should be pretty quick. Tomorrow's Monday. I plan to record the other half of the lecture for the next section, or I plan to record the last lecture for this section tomorrow, but it won't be half. There won't be labs on it until the next unit, which will be the last unit. So, sorry, my mind's in a jumble. Processing data, personal data since PDAs have been mostly replaced by PDAs. Wow, mostly by iPods, and not even those are dead. iPads are still around on other mobile devices. Their use has shifted to more specific markets such as medical or industrial PDAs. Not even that. If you go to the doctor, well, I mean, I go to Kaiser, hypothetically now. They don't even use PDAs. Those are gone. Sometimes I'll have an iPad and record like what I said in terms of like my health and all that. Everything doing it at a computer station. So I'm not sure how accurate that PDA thing is anymore. Peripheral memory cards use PDAs, compact flash, multimedia card, secure digital SDGs. All of these standards are kind of dead because now it's micro SD or even nothing anymore cloud-based now too. So it's kind of old information. Subscriber identity module SIM card. So that's what SIM stands for, if you ever didn't know. Found most common in GSM devices, consist of a microprocessor and internal memory. GSM refers to mobile phones as mobile stations. Devices stationed into two parts: a SIM card and mobile equipment. SIM cards come in three sizes. Portability of information makes SIM cards versatile. Subscriber identity module SIM cards continued. SIM card is necessary for ME to work and serves these additional purposes. Identifies the subscriber to the network. Stores service-related information, can be used to back up the device. Many phones now include SD cards for external storage. Even that's going away, guys. I mean, your phones are now baked in. I mean, I have an S20. Excuse me. I jumped from an S10 when I got my S20, and they got rid of the micro SD slot for onboard flash memory, so it's faster, and it can store up to like half a terabyte of information, but I don't use that much info. So, I mean, yeah, I guess the older, cheaper phones now would have SD cards. Moving forward, they aren't doing that anymore. It's all baked in flash memory, so it's weird. The main concern with mobile devices are loss of power, synchronization with cloud services, and remote wiping. All mobile devices have volatile memory. Make sure they don't lose power before you can retrieve RAM data is critical. Mobile devices attached to PCs via USB cable should be disconnected from the PC immediately. Helps prevent synchronization. The might occur automatically and overwrite data. Depending on the warrant or subpoena, the time of seizure might be relevant. Messages might be received on the mobile device after seizure. Isolating the device from incoming signal with one of the following options. Place the device in airplane mode. Place the device in a paint can. That's one I've never heard of. Use a Faraday bag, or you can make a Faraday cage. Turn the device off. The drawback of using these isolation options is that a mobile device is put into roaming mode. Accelerates battery drainage. SNS, DFIR, forensic methods. If a device is on and unlocked, isolated from the network, disable screen lock, and remove passcode. If the device is on and locked, what you can do varies depending on the type of device. If device is off, attempt a physical static acquisition and turn the device on. Check the areas in the forensic lab. Check these areas, sorry. Internal memory, SIM card, removable or external memory cards, network provider. Checking network provider requires a search warrant or subpoena. A new complication in the service because backup might be stored in a cloud provided by the carrier or third party. Due to the growing problem of mobile devices being stolen, service providers have started using remote wiping to remove approved personal information stolen on a stored device. Memory storage on a mobile device is usually a combination of volatile and non-volatile memory. The file system for a SIM card is hierarchical in structure. That's what that SIM card looks like in structure. Right, moving on. 17 more slides, guys. We're getting there. Information that can be retrieved falls into 4 categories. Service-related data, such as identifiers for the SIM card and the subscriber. Call data, such as numbers dialed, message information, location information. If power has been lost, PINs or other access codes might be required to view files. Mobile forensics is involving science. Biggest challenge is dealing with constantly changing phone models. Procedures for working with mobile forensic software. Sorry, guys. Identify the mobile device. Make sure you have installed the mobile device forensic software. Attach the phone to power and connect cables. Start the forensic software and download information. SIM card readers. A combination hardware-software device used to access SIM cards. You need to be in a forensic lab equipped with appropriate anti-static devices General procedure as follow. Remove the device's back panel. Remove the battery. Remove the SIM card from the holder. Insert the SIM card into the card reader. Yeah, that's how it was maybe like 5 years ago, but let me take the case off my phone. Here, give me a second. The reason I'm saying take off the cases. Yes, I have an S10. I'm gonna do this to rub it in. It's hard to see, but right here, stupid thing. Right here by my finger. If I point it, it doesn't. Oh, there it is. Let me bring it close so it disappeared. It's hard to see, but there is a pin holder you push that pops the SIM card out, so you wouldn't have to take the phone apart. Even some phones nowadays don't come with SIM cards; they're built into the memory of the phone or baked onto the motherboard of the phone. So yeah, that's kind of still true, kind of isn't though. It's one of those depending on the situation. So variety of SIM card readers are available. Some are forensically sound and some are not. Documenting messages that haven't been received yet is critical. Use a tool that takes pictures of each screen. Mobile phone forensic tool methods: access data FTK imager and MacLock PIC 3.0, which probably up to 5.0 nowadays. NIST guidelines list 6 types of mobile forensic methods. Manual extraction, which are pretty simple. You plug it in and your computer can read it and allows you to copy the information, do it. Logical extraction, physical extraction. That's when you kind of like physically take it apart, I'm assuming, and mount parts of it. Hex dumping and joint test action group, JTAG extraction, chip off, and micro read. I kind of like, I'll be honest with you guys, I kind of like slide 26 to make an assignment out of it, and I'm going to reface this and might be an assignment where I have you look up each of these methods and write about them briefly instead of making a lab. Because I know like labs are fun and all, and they can get a little boring, but I don't know. I'm thinking about it. And if I have you guys look all this up and have you guys write about it, it might be something you learn more about than just do this for FTK or use this in forensic OS or et cetera, et cetera. It's just how I'm thinking. Paraben software offers several tools. E3DS for mobile device investigations. Data Pilot has a collection of cables that can interface with phones from different manufacturers. BitPam used to view data on many CDMA phones. It's older style phones. The problem they're having now, this is mostly in the field with forensics, is I don't know if you've seen these phones. Maybe you guys haven't. This is more of my generation. If you haven't, it's cool. Let me pull up let me pull it up over here on screen. Give me a second. Yeah, it's an older Nokia phone. And the running joke is these things were indestructible back in the day. Yeah, here's what they look like. I'll pull it up. I won't pull up an Amazon. I'll pull up some information about me. I don't want. You guys don't need to know where exactly I live, but here's what they look like. Yeah, it's fine. Like this. Maybe this is a blue one. You could drop this thing, and this will break off back, or break off in the center, it would be by itself, and even breaking half of the board by itself. These are really old. Okay, these are back like early 2000s, and since they're kind of ancient now in terms of technology, they're not really used too often. Well, the problem with that is, since they're so old, it's getting hard to find cables for them, and it's getting harder to track them because they're running on an even older style of network. It's before even 3G. So that's the problem police are having nowadays. Oops, that's just the schedule of what we're doing every week. But sorry about that. But that's just a little tidbit of information. So how these will interface with that, I'm not even sure, to be honest with you guys. It might not even apply to most of these because with phones like that, back before they had Android or even iPhone before they existed, you would plug them in, your computer would seem just like almost a giant flash drive. And those were the days of like Windows 98 second edition, Windows 2000, Windows ME, which we don't talk about, and Windows XP prevalently. So this is way back in the day. Anyway, before was I? BitPam and Cellbrite. I use this Cellbrite. Sorry. UFD forensic system works with smartphones, PDAs, tablets, and GPS devices. That's still pretty common. Mobile DIT forensics contains a built-in writer blocker. That's pretty cool. So software tools differ in the information they display and the level of detail. Some tools are designed for updating files, not retrieving data. Yeah, but I can see why, but I'm trying to figure out how to explain it. But I mean, it's kind of weird for a phone since it's not really a computer. You know what I mean? And the memory is volatile. If it gets overwritten and you needed that critical piece of information to prove a person guilty, you're kind of hosed, right? So I get it, I guess. In general, tools designed to edit information, although they are user-friendly, usually aren't forensically sound. Cellebrite is often used by law enforcement. You can determine the device's make and model, learn what has to be done before connecting a mobile device to the UFED device, and then retrieve the data. 3 options for data extraction: logical, file system, and physical. You use all 3 probably, just to verify and have copies. You can also simply connect a mobile device to your computer to browse the file system and examine and retrieve files. You need a USB write blocker though, so it doesn't overwrite anything. So yeah, see this when you're looking at Android, it looks, it just treats it like a giant flash drive, essentially. Technically. Where are we? 8 more slides. Early steps in accessing a mobile device. We have to grant access. This is what Axiom looks like. We'll pop it with Axiom in the slide, don't worry. Or this unit. Many mobile forensic tools are available. Most aren't free though. That's the problem. Methods and techniques for acquiring evidence will change as market continues to expand and mature. Subscribe to user groups and professional organizations to stay abreast what's happening in the industry. They were not Reddit's a pretty good resource for this kind of stuff because they're pretty up to date. In 2010, oh lord, VMware and BlackBerry were developing Type 2 hypervisors for mobile devices, useful for security, protecting personal information, but will add another level of complexity to forensic investigations. But BlackBerry is technically dead at this day and age, right? When was the last time you heard someone say BlackBerry? Separate personal information from business-related data. Bring your own device. Practice makes it even more difficult. Yeah, that's where it intersects with personal life. So if they committed a crime on their personal life, it'll work. You only look up to the work network part. You can't get into the personal device without a separate warrant. It's a mess. Here's the IoT, the Internet of Things that I was talking about. The number of devices that connect to the internet is higher than the amount of people. The number is expected to reach 50 billion in the next few decades. I mean, basically, even your home can be smart now, right? Even your windows, washer, fridge, built-in camera, so you can check it from wherever you are on your phone. What else can I think of? Thermostat, lighting, almost anything, right? Evolution from Internet of Things to Internet of Everything to Internet of Anything. I guess. IoE adds features that aren't tangible but are widespread on the internet. Google search engine and YouTube. I guess. IoA includes cars, homes, pets, livestock. I don't know how the hell you would connect your. Well, I mean, I'm thinking of sheep in the sense of how you connect sheep. I'm not thinking like apple sheep. I'm not doing this and saying you insult anybody, but like horses and stuff. Well, I guess if you tag them right, and that tag sends a frequency back and connects to the internet to send you their location via GPS. I guess that's how it works. I'm just trying to make sense of it, guys. That's all. And applications will make all these things work together. Eventually, will include 5G smart devices. 5G device categories, enhanced mobile broadband, EMBB, ultra reliable low latency communications, URLLC, massive machine type communications, MMTC. 5G devices include new challenges for digital forensics, people to device communication, device to device communication, device to cloud communication. I think D2C is the hardest one to deal with now too, because device to device is a log on either device. People to device is very straightforward, but device to cloud can get really squirrely. Wearable computers will pose many new challenges for investigators. Vehicle system forensics address many parts that have sensors in cars. So here's a summary. People store a wealth of information on smartphones, including calls, texts, messages, pictures, and music files, an address book, and more. Mobile devices have gone through 4 generations: analog, digital personal communication devices, 3rd generation, and 4th generation, 5th generation. Sorry, standards are being negotiated and developed by the IMT 2020 working group, the International Union. That's already done by this point, guys. It's 2023. I guarantee you they're done. Mobile devices range from basic, inexpensive phones used probably for phone calls to smartphones. Everything's a smartphone practically nowadays. I forget what's the name of that big smartphone company that isn't allowed here in the US. It's not Tencent. I forget their name, but they're pretty big in Africa of all places because they kind of dominate the market and don't. Even Samsung and Apple isn't too popular, I think, because of them, or LG. Just, if you're curious, look it up. Data can be retrieved from several different places in phones. Use of personal digital assistants has declined due to popularity of smartphones. PDAs are practically extinct. As with computers, proper search and seizure procedures must be followed for mobile devices. To isolate a mobile phone from an incoming message, you can put it in airplane mode, turn the device off, or place it in a specially treated paint can. Sorry, I can't get over that. That's pretty funny. Or evidence bag. They forgot Faraday bag or Faraday cage. You can look up what those are. I'm not going to get into it. SIM cards store data in hierarchical file structure. Mobile devices forensics is becoming more important as these devices grow in popularity. Many software tools are available for reading data stored in mobile devices. The Internet of Things, IoT, has resulted in yet another challenge for digital forensics, or forensic investigators. Digital forensics, I guess, works too. Collecting information from wearable computers will pose many new challenges for investigators. All right, guys. That's all I had for this one. I will catch you in the next half chapter, and that'll be it for Unit 5. See you then.